This is R.D. Sharma Solution, Class 12, Chapter 10, Differentiability, MCQ, multiple choice question we are taking. Before we go ahead, let me tell you that in R.D. Sharma and other NCERT books, initially these questions are MC questions and the VSAQ questions. They're already being covered in the exercise, for example, 10.1, 10.2, of course, in VSAQ, very short answer question. So you need to watch all those and then you can be appreciating these solutions. Okay. I would request you to please go through all of it and then you'll understand this better. Let fx equals to modulus of x and gx is equal to modulus of x cube. Then, so all these options are asking for the continuity and the differentiability of these fx and gx. Just for a revision, let me tell you again that if any function is differentiable, that means it is a guarantee that it is continuous also, right? But if a function is continuous, then there is no guarantee that whether it is differentiable or non-differentiable. We don't know that. We have to check it. So those who want to do this question try themselves, they can just have a look and they can get a reference. And those who want to actually know how to solve this question, what will be the answer, you can just go along with me. So this is a function which we have been using a lot. We have been discussing a lot. This is the graph of modulus x. So when you take a ride on this route, there is no break. So this function is continuous. Okay. So this is continuous everywhere. But at this, you can say sharp turn, if you take left and right, then you will get two tangents with a different m, tan theta or slope. That means it is not differentiable at this point, at origin you can call. But modulus of x cube, how to do that? So this modulus x, I hope you'll be able to do by yourself. I hope. And modulus x is for you because you can just go through all these previous discussions. And by graph also I showed you that why it is continuous, why it is not differentiable. The sharp turn, sharp edge, that means that differentiability may not be there, but still we have to check with all the formulas and the expressions we have to actually do it. So modulus x, I hope this can be done by you guys. Now coming to this modulus of x cube, that we are definitely going to see. Well, it also is similar to the modulus x because it is just x cube, but it is inside modulus. So let us check it. The last one is incorrect because the modulus x is not differentiable. Okay. And modulus x, we have already talked about modulus x cube. Whatever is inside modulus, it will always give you a positive and a negative value. So that point where we have to check, if you go up, that is, it is going to be positive value, for example, x minus 1 modulus. So you just have to check whether when x minus 1 is equal to 0, it is x equals to 1. So when you go up 1, it's positive. When you go below 1, it's negative. Similarly, this gx, it will be positive x cube because it is just a modulus sign. So you have to put a positive when x is greater than or equal to 0 and negative x when it is less than 0. So how to check the continuity? Left hand limit and right hand limit both we have to take. So we have to put x as 0 minus h, x as 0 plus h. Okay. So essentially you have to put minus h and plus h. Then we will apply the limit. Please remember, limit 0 minus means or some value minus means you are on the left, 0 plus or some value above it, if it has a plus, that means you are talking about the value on the right of it. So minus x cube we are using because we are less than 0, greater than 0, we are going to use the x cube. Okay. So in place of x, replace it by negative h. Now you can change the limit. The limit needs to be changed. It should be limit h tends to 0. Okay. So this is minus negative h. So limit h tends to 0. Here also limit h tends to 0. And minus of minus h cube. So it will be minus, because negative power of odd will always give you negative. Negative becomes positive. Right hand side also you get a h cube, that is applying the limit you get a 0. Okay. So left hand limit and right hand limit are same, and let us check the value at the of the function at 0. So where is the equality? It's x cube. 0 cube is 0. So left hand limit and right hand limit we have already checked now. And the value of the function at 0. So this is continuous, that we have verified here. Right? Now coming to the other differentiability part. So whatever we are doing, just keep an eye on the answer. Where it is continuous, where the function is not continuous or differentiable, non-differentiable, that's how you're going to give your answer or select your answer. Before we actually find out what is the exact answer, we need to check the differentiability also. So left hand derivative and right hand derivative we are checking. Okay. This x is 0 minus h, and this is x equals 0 plus h, that is h only. That we are going to put in x equals, because we are going to check at x equals to 0. So limit x tends to c, fx minus fc divided by x minus c. So x is 0, so in place of c, this is c equals 0. So wherever we have c, replace it by 0. Now we have to go to left hand derivative and right hand derivative, and you have to use the function accordingly. If you are below 0, you have to use negative x cube, this one. And if you are above 0, you have to use x cube. Okay. So f0, I told you already, f0 we have already checked just now in the continuity. f0 is 0 only. So minus x cube in place of fx minus fc, that is 0, divided by x minus c, that is minus h minus 0. So minus h you can replace here, but I'll just replace it. But let us see the right hand derivative also. Right hand derivative, you have to put an x cube, and then we have 0, fc is 0, f0 is 0, we already checked it. And no x minus c, in place of x you have to replace it by h minus c, c is 0, so it will be h in the denominator. So this is limit x tends to 0 minus, and the right one is limit x tends to 0 plus. But now we'll change the limit h tends to 0. We'll replace x by minus h in the left and by x as h on the right. So this is what you have to write everywhere. There is a point where the limit will change also. Now this is h cube by h. This gets cancelled. You have minus h cube, that is going to be minus h cube only, because it is odd power, and denominator you have h. So this gets cancelled. It will be minus h square. Here also it will be h square. And when you apply the limit h tends to 0, you are going to get a 0 on both the sides. This is 0 and this is 0. Okay. So left hand derivative and right hand derivative, they are matching. So you can say the modulus x cube is continuous also, differentiable also. Mod x is continuous but not differentiable. Accordingly, please choose the answer. The function fx equals sine inverse cos x is discontinuous at x equals to 0, continuous at x equals to 0, differentiable at x equals to 0, none of these. So see, differentiability needs to be only checked after you have checked for continuity. But if you have checked directly for differentiability, and if it is differentiable, you don't need to check it for continuity, because it will be obviously continuous. Alright. So we have this function f(x) equals sine inverse cos x. So you have to check at x equals to 0. This is given already in the question. So this is sine inverse cos x. So in here x equals to 0 you have to put. So left hand limit and right hand limit we are going to compute. Left hand limit, right hand limit. So we have to put x as 0 minus h in the left hand limit, x as 0 plus h in the right hand limit. So basically it is sine inverse cos 0 minus h. Here it will be sine inverse cos and 0 plus h. So sine inverse cos negative h, and cos minus theta is cos theta only. Okay, cos minus theta is cos theta only. And then we have sine inverse cos h. So cos h both inside. You can just apply this limit. Limit h tends to 0. Here also limit h tends to 0. And this is cos 0 is 1. So cos 0 is 1. So sine inverse 1 it will be. Here also sine inverse cos 0 is 1. Now sine inverse, what is that? Sine inverse theta equals, say x equals y. Let us see like that. So x will be equal to sine y. What is the value of y so that sine of it will give you 1? It is pi by 2. Sine 90 is what? It is going to give you 1. So the answer is pi by 2. Now you will say 1 can come in many cases. Okay. Sine 0 is 0, so it passes through the origin. And this 1 is going to come because this sine is never ending. It always oscillates between -1 and 1, but on the x-axis it is never ending. Okay. So this can be 2n pi plus or n pi plus, that you have to decide. So there can be multiple solution of this, but here we are just restricting ourselves to the first quadrant. Okay. So continuity we have already checked. LHL and RHL both were the similar value, and the value of the function at 0, which is sine inverse cos 0. Cos 0 is 1. Again sine inverse this 1 is pi by 2. So this is continuous. This function is continuous. We have already checked it. Okay. Now coming to the second part, which is the differentiability. So we have to check for the differentiability as well, and then we can decide what will be the suitable answer for all these options which are provided to us. So left hand derivative, right hand derivative. The function is fx minus fc by x minus c. Limit x tends to c. So c is 0 here. It is already given. f0 we have already found out. Pi by 2 I am going to directly put in here. So this is x equals 0 minus h. This is x equals 0 plus h. That is negative h on left and positive h on here. Right? So this is limit x tends to 0 minus, limit x tends to 0 plus. This just shows which function you have to put in. But we have to use fx, both the cases same thing, because fx is sine inverse cos x. So this is sine inverse cos. We just have to put 0 minus h here. Minus, as I already told you, f0 we have already done. That is pi by 2. So replace it by pi by 2. And then we have this as the denominator. And that is x minus c minus h minus 0. That is going to be negative h. Here also same thing, sine inverse cos 0 plus h. So you can replace it by h. Minus pi by 2 because fc will remain there. And then in the denominator it is 0 plus h, that is h. So let us put it like h. Okay, now we cannot go ahead just like what we have done in continuity. Because this cos theta, you can always write it as sine 90 minus theta. So I am changing the limit. Limit h tends to 0. And this is also, see, we need to write this because cos minus theta is plus cos theta. So you can just write that as cos h. So we'll try to cancel this sine inverse and sine, because we know that cos theta is sine 90 minus theta, and cos 90 minus theta is sine theta. That we already know. So cos theta, you can write it as sine pi by 2 minus h, and in this cos h, in place of cos h, we are just replacing it, minus pi by 2. So you can just cancel these two out. Pi by 2, numerator I am telling you, pi by 2 minus h minus pi by 2, minus pi by 2 minus pi by 2 cancel out, and minus h by minus h, that is going to be 1. So limit h tends to 0, you have 1 here. Here also, same way we are going to go ahead, sine inverse. In place of cos, write sine 90 minus theta or pi by 2 minus h, minus pi by 2 divided by h. I'll just take it, sine inverse cancel, pi by 2 minus h minus pi by 2 is going to give you negative h. In the denominator you have a h. So this gets cancelled, you have a negative 1. So the left hand derivative is 1, right hand derivative is negative 1. That is, they are not matching. When they are not matching, that means this function is not a differentiable, but it is continuous at x equals to 0. This is how you will choose a suitable answer from all these 4 options. The set of points where the function fx is equal to x into modulus x is differentiable. Differentiable where? Modulus x, you are completely aware by now. How this modulus function works for simple x, what is the graph of this function, we have been talking every time, okay? So mod x, just to revise, x is greater than or equal to 0, it is x. It is negative x when x is less than 0. So x into modulus x, you just multiply it by x. Will not change. So x into modulus x will be x square when x is greater than or equal to 0, and negative x square when x is less than 0. So x is greater than or equal to 0, x is less than 0, we've got the value. So these intervals, if you see, there is a 0 also involved. And because it is round bracket and square bracket both, so 0 is included somewhere, 0 is not included somewhere. So we have a closed interval and open interval as well. So what we have to do here is, if you just put 0 in place of this fx, f0, it will be 0 into modulus 0, which is essentially equal to 0 only, right? So what will be the final, I'm just dividing this. So x square when x is greater than 0, it is negative x square when x is less than 0, we don't have any doubt about it. But it is 0 when x is equal to 0, which we already checked just now. So x into modulus x, I divided into 3 parts now. Just below 0, above 0, and then on 0. So this minus x cube and x square, they both are polynomial. So this negative x cube and x square, they are polynomial function. They are continuous and differentiable in the interval from negative infinity to 0 and 0 to infinity. So we have to check the continuity and the differentiability. We just have to check differentiability, because the question is not asking about continuity. We just have to check for the differentiability. This x square, see, 0 to infinite, it will always be positive. You put any value in x, it is from 0 to infinity always positive. On negative x square, if you put any value from negative infinity to below 0, it will always be negative. Right? So if you take a number line, just to show you what we are intending, negative infinity to 0 and 0 to plus infinity, this is all okay. But we still have to check at 0, because we are not checking at 0 right now. We have a separate value which is 0 at 0. So at this point, whether there is some say sharp turn, sharp edge, or the graph is, say, taking a sharp angle theta differently, that is what we are interested in. So the left hand derivative and right hand derivative, fx minus fc by x minus c, limit x tends to c, this is what we are going to do, which we always do, right? So here we have, when we are from negative infinity to 0, we'll use negative x square. When we are from 0 to infinity, we'll use x square. This is by the function also. And this we are directly going to put at fx, and fc, which is f0, is already 0. That already we know. f0 is 0. This we already know. We have already checked it and showed it to you also. So minus x square minus 0 divided by x minus c. In place of x, you are going to put 0 minus h. So 0 minus h, 0 minus h minus 0 is minus h only. Here also same thing, x square, because x is greater than 0, minus 0 divided by, then we have x minus c, so 0 plus h minus c 0. So you have this as h only. So what do you get here? H. Now first you have to write limit x tends to 0 minus and then 0 plus on LHD and RHD. Then when you put h, replace x by 0 minus h or 0 plus h, then you have to change the limit to limit h tends to 0. That you already know. I am not writing it again and again. That you can just see the reference of solution which I always provide. So you have minus h square and divide this minus h square by h, minus minus cancel, h cancel, you have a h. When you put h tends to 0, it becomes 0. Here also you have h square by h, 1 h again, and limit h tends to 0. When limit h is tending to 0 or approaching 0, it is 0. So left hand derivative, right hand derivative, both are same. It is differentiable. And from where? It is differentiable at x equal to 0. It was already minus infinity to 0. It was differentiable and continuous. 0 to infinity also, but we have already checked at 0. So you have to include 0. So it is from negative infinity to positive infinity. You can safely say from negative infinity to positive infinity, it is differentiable. First option is the correct answer. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.